specific related to Snowflake?
No, data warehouse concepts like Snowflake.
Okay.
Yeah. Snowflake is like one of the data warehouse, So whatever the DBs we are considering, all those are data warehouses.
Okay.
So I'm not dealing with any particular data warehouse, but I just want to generalize what is the data warehouse and what is the main purpose of that and how we are dealing that thing. First of all, how many types of databases are there? All these things we need to know. Then we can go with it. You want to learn Snowflake, Shrikant, or what? How it would be? You are looking into that
No, no, no.
particularly? Mm.
Not anything in particular. Thought,
Mm.
I mean, I have little bit of knowledge about it. That's it. I mean,
Yeah, yeah, that would
very
be.
little. I mean, oh,
Yeah,
you
that
can.
is great. Very little is also fine when we are starting. Okay, I'm sharing my screen. As we have already discussed all these things, so we are directly going to the data warehouse concepts. Before going forward, I just want to make sure that everybody must be familiar with this diagram, what we are going on. So this would be our entire process when we are doing the data engineering. So what is the first step? We are having source, and like I'm giving an example. Like we already discussed, data engineering is nothing but like a Swiggy delivery. We are getting data from our data or some food parcel from one hotel, and what we are doing, we are taking one vehicle. Okay, and then we are going into the destination. So this is what the main basic thing. So after the destination, who are taking this, who are collecting this? Collected by analytics team. So here it is the source. What is the source? Anybody from you? Actually, we have
Can be
discussed.
any ERP system,
Yes, yes,
flat
very good.
files,
Yes.
databases.
So we are having ERPs. ERP is nothing but enterprise resource planner. But we need not to learn any ERP here. ERP is our source. That's it. Don't think too much about what is ERP and all. Just remember that ERP is a source to data engineer. It's not. Any ERPs. So from ERPs, we are getting data. Those would be like some of the examples for this is SAP, SAP, Oracle apps, and Salesforce mainframes. So this, whatever it may be, before going to anything, you must know the background of that any technology, what is background and why we are going for that, and what is our work there, that should be known first. So we are taking ERPs, and the ERPs we are having many ERPs, but I'm taking some examples like SAP, Oracle apps, Salesforce, mainframes. These are all what? These are all sources. So from different sources, we are connecting and collecting the data. So any big data, any data engineering, the main purpose of that is like it is store once, read multiple times. So whatever why we are going for data analysis, we have already discussed what is data warehouse, why we require data, and what is that. So what I'm saying is, just remember, you are extracting data from from different sources, and we are moving the data to a temporary storage, and we are doing all the transformations in that. So from this ERPs, what we are doing, we are to the source. Either we can connect directly because they will give our access to connect these ERPs, or they will push the data into our staging. So here we can connect and collect the data. What we are doing here, we are connecting and collecting the data. So this is very important. That's why I'm taking some time for you to understand. Connect and collect. What we are doing, connect and collect the data from ERP to where it is a staging. Staging is nothing but temporary storage. This is very important. Please pay attention. In this, what we are doing, this is also called as temporary storage or big data server. Big data server. So the example for this is, I can give you some examples for your purpose. Like you can take Spark, and all ETL tools, whatever we are using, Informatica, many are there. We are using ADF also, one of the ETL tool, right? So we can consider Informatica. So what this ETL tool is doing, it was connecting and collecting the data and doing some transformations. As simple as that. Don't get confused in this. ETL. So our work is in between source and the target. So what we are doing, we are collecting the data, we are applying all the transformations in the big data server, and then we are giving this data to where? Data warehouse. Okay. That's why you must know the difference between source and target. So this is a target. This target is something with any database warehouse. Any database it would be, like Snowflake. Like you told, like we are having Snowflake, and sometimes it would be SQL Server, and sometimes it would be Synapse Analytical Platform, Synapse. So all these are all like some of the examples for data warehouses. So the destination would be any data warehouse. So what we are doing from here to here, what we are doing, we are loading the data into target. here we are collecting and connecting and collecting the data, and we are loading data to the target. Okay. And who is he? Anybody? We have already discussed this diagram.
BA tool.
Very, very good. So who are collecting this data from data warehouse? That is BI. And now what we can say, any BI tool, Power BI. I'm giving one example. That's why Power BI people is having more demand, because whatever we did the data, like enriching the data, and we are doing everything in the staging, so that can be given to the data warehouse. From the data warehouse, the data is collected by this BI team, analytics team you can call. So analytics team will do all the aggregations according to the business rules and requirements. So after doing all those things, like some aggregations and all these things, they will give this data to the required client. Like they were asking, like this which product is making more profit and like that, and which product is not selling at all. So that kind of information will be given by BI team to the client. So this is what we are doing. So we'll have one simple small doubt. Why in between these things? Like why we need some staging, why we need target, why can't we connect directly from analysis team to ERPs? So this is what the question actually. Everybody will get it, right? Why we need data engineers in between? Why can't we are going directly to the any ERP, and we are collecting the data, and we are doing all the aggregations and required if you are fetching the data, and you can directly do that, right? But why we are not able to do that, and why we require all this setup to do this? So if you got this question, then that would be the right way of thinking. So you can directly connect source to analysis stream. Why we require all these things? Why we require means there are two different kinds of databases. So due to this two different kinds of databases, it is not able to connect direct one database to another database. The simple thing is, whatever we are doing that source, this is called as OLTP. This is the main and major, like what you can say, this was very important concept before you going further into the data engineering. Because if you don't know OLTP and OLAP, so it is like complete mess what you are going to do. You are migrating data and everything looks fine, everything fine, but what is the backbone of this thing? Why we are migrating? What is the purpose of migration? And what is the purpose of this analyzing, and why we are uploading in some target, some staging? Because these two are whatever the ERP and this analysis, like where we are getting this data is different. This is OLAP and this is OLTP. These are two different databases. I'll explain you what is OLTP and what is OLAP. Don't get confused. So to connect between OLTP to OLAP, we need all this setup in between. Okay, this is where we got the exact data warehousing concept. As of now, we know that why we require that data warehouse and what we are doing with that data warehouse. We are collecting all kinds of data inside this data warehouse. As we already know that data warehouse can contain all kinds of data inside it. So among all those data, this analysis team is fetching required data, and they were doing all the analysis, and they were giving the report to that required whoever requires this report. But the main difference is this is OLTP and this is OLAP. And what is OLTP and what is OLAP? Now we are going deep inside. OLTP is nothing but like so in this what we are doing, and in OLAP what we are doing, so we must know that online transaction processing. OLTP is nothing but we are having two types of databases. One is OLTP. This would be it where source. What is this? OLTP is nothing but online transaction processing. And what is OLAP? OLAP at where? BI, right? Analysis. Online analysis processing. So what is the difference between OLTP and OLAP? OLTP is nothing but I can give you a simple example where you can understand by seeing this. So, all bank transactions. So you are doing some transaction, you are debiting, you are crediting the amount and doing all these things. This will comes under online transaction processing. And I can take some supermarket also as an example. So what you are doing, you are going and like you are paying all the things like this will come under OLTP, means online transaction processing. Then what is OLAP? A simple example for this is whatever the statement you're receiving from the bank, that is OLAP. So what would be there in the statement? In statement, past history of your transactions. So what is the difference between OLTP and OLAP? OLTP, you can do whatever so all the DDL operations in OLTP, means what I want to say is in OLTP you can do the change, like whatever you require, you can do the changes in the data. But whereas coming to the analysis part, you can't do any change. Means it is simply a historical data where we are getting. Suppose if you take any statement of your bank, suppose I'm taking past 1 month data. So is that possible? Like I want to change in that data. I want to do some transactional change in the last month data. So it is not possible. So what is main motive I want to explain behind this is OLAP is nothing but it is just analysis, and we are going for the historical data. You see in this picture also we can find we are getting all the data, and this data is OLTP. So in the sources the data is going to be changed continuously. So this change data is collected here, and once the data came here, it won't be the same as before, right? Here we can get a lot of changes here. But once the data is extracted here, once the data is collected in this staging, or once after doing all these operations, what will be there? The data would be historical data. So the simple example, what I'm going to see, you can change the transaction, what transaction you want to do. Suppose if you want to do 100 rupees payment, then it's okay, you can do it. You can do 80 rupees payment also. But once the payment done, once it became history, then it would come under the OLAP. This is online analysis processing. So analysis is coming for which data? It is for historical data. It is not for transactional data. Okay, the transactions already made and that data is now became history. So that is the historical data we are treating. So this database is different and this database is different. This is OLTP and this is OLAP. That's why we are connecting these things, and that's why we require one data engineer to move the data. And what we are doing in the staging, as you already know that I explained, we are enriching the data in the staging, right? So what is the enriching of data? Anybody can tell? Like removing nulls. So what we are doing here in the staging?
Whatever transformation we require for target, so we are doing here.
So we are doing, yes, right. We are removing nulls and we can clear the junk data. And we can remove the duplicates. So all these things are done in this staging. And we will do some transformations. Okay, so we need, if we need to remove some fields, we can remove fields and records. So all these operations done at ETL. So the ETL would be Spark, Databricks, or you can consider Azure Data Factory. Going forward, we are connecting to Azure Data Factory. Then you can see all these things. So these things are done in like on the OLTP. After connecting the data inside the ETL, we are doing all these things, and then this would be loaded into data warehouse. Under the data warehouse, we are having different kinds of data, various like you can't say one type of data. You can't say sales only. We are having many kinds of data, different customers, sales, employees, orders. So all this data would be here. So it would be extracted by this analysis team, and they will extract and they will do whatever the aggregations they want to do, and they will collect from the data warehouse, and they will do the analysis. So this data, whatever we are getting from target, that is historical data. See here. What is OLTP system? Database systems have been used traditionally for OLTP. So in this, what you are having, data processing tasks, and like the data is going to be detailed and updated data. So this would be different than the OLAP. OLAP is simply historical data. OLTP, I can give you some examples like banking. So it will immediately affect the database. So whatever you are doing, the OLTP will immediately affect the database. Immediately affect the database, and we are having more DML operations here. What are the DML operations?
Data manipulation means insert, update,
Yes. Update,
Delete.
insert,
delete.
delete. So these operations we can do on OLTP. So the examples for this is all ERPs and supermarkets and whatever we are having, whatever the transactions happening inside that database, that comes under OLTP services. Then what is OLAP? OLAP is having mostly historical data. That's it. Suppose if you are taking nowadays, previous days we don't have this UPI, right? Now we are having UPI. Under the UPI, we can even pay 5 rupees, 3 rupees, 2 rupees also. So the history is going to be large nowadays because we are paying everywhere UPI. So the first 10 transactions would be there, that would be shown to you. So to get the quick statement, you can see the first 10 transactions like that. Then if you want more transaction details, that will come for the OLAP. Okay, so whatever the statement you are getting, that would be OLAP. So whatever the transactions you are doing and whatever the changes it is happening to the database immediately, that would be OLTP. Okay, So I think it would be clear till now. So any doubts you can ask me. I will show you that also. Data warehouse defined in many different ways, but no rigorously. So the data is not going to be changed continuously in data warehouse. Data warehouse, we are having the data that was historical, right? So this is what the OLAP. That's why we are not able to connect OLAP to directly OLTP due to the database difference. So we are having mainly two kinds of databases anywhere you go. So one is OLTP and one is OLAP. OLAP, so this is a difference. See, OLAP is for analytics, and the queries also like weak and denormalization, normalization. I'll go through that whenever I'm teaching the SQL. Then you can know that. And what are the historical data we are having? That would be in the OLAP, and OLTP we are having all the DML operations done immediately to the database, and that would be transactional. And that is current data, what is happening to the database. Means the best example for this, banking DB is the OLTP. So whatever the database they were using, bankers, that would be OLTP. And what we are fetching the data, that would be OLAP. So this is the main difference. I just explained you. Like if you have any doubts, you can ask me now. That's fine. You can continue. See here, OLTP DB, OLAP DB. What is, both are used for business purpose only. Both are business only. But OLTP is the database where we are getting the immediate changes reflecting in the OLTP database. So if you want to get the statement, that would be OLAP. So you can't go back and you can change the statement, right? It is not the case. So 2 months past statement, if you take it, you can just watch and you can analyze what is your expenditure, how you are paying the bills, and how would be your income, and how you are managing everything. You can watch the statement, but you can't do any changes. You can do some operations by analyzing that thing. It doesn't change database data. Whereas coming to the OLTP, so it would be continuously changing. You, for your account, you having one table in the database. So what it will do when you having 1 lakh in your account, so you drawing some 20,000 rupees today. So it will immediately reflect in that table in the database. So the changes in the data is going to be happen in the database. The simple idea behind this is whatever you are doing, that would be reflected in that. Whereas coming to the OLAP, can you go back to the 2 months back and you will change that statement? Is that possible? I'm trying to like get you the complete picture of OLAP and OLTP. That's why I'm pressing this much on this, because this is a main background of our data engineering. We are going forward. So if you don't know these things, then this would be completely miss. That's why I'm asking you. So is there, like, you can go back to the 2 month statement, you can change the required changes in that statement? Anybody? That is simple, right? People are getting or not?
Yes, we can't.
Yes, Divya.
Yeah, this OLTP, actually OLAP everybody can understand because you're just getting the historical data. But what is OLTP? Going forward, you will get confused because it would be simple now, but going forward it would be different. So OLTP is nothing but whatever the data changes you are doing, that will be directly implicated over the database. Simple example for this is you are withdrawing some amount or you are depositing some amount. It would be do the increment in your database. So the number of fields are going to be increased in the database. I'll give you through Excel. Suppose I'm giving some ID, name, amount. credit, debit. It would be different, but I am just giving. Suppose I'm giving one, Vijita, second, and then amount she is having some 3,000. Next, Srikanth. Yeah. Suppose this is the amounts we are having. This is one database. For this, what Vijita did is she went and she withdrew some 20,000. So what will happen to this table now? It's debit updated and the amount is going to be decreased to amount. Now it is going to be 30,000. So whatever the thing we are doing, due to that, this database is updating. Here deducted and it became 30,000. Okay. So debited 20,000. And again she went back. So it would be like this. Her statement would be like this, 50,000. And then she debited 20,000. Now what happened to this amount? It became 30,000. And again she deposited some 10,000. Now it is going to be 40,000. Right? This is continuously changing. The amount what we are having, this is continuously changing, and the credit and debit also continuously changing. So this kind of database, it's continuously changing whenever we are doing some transactions on this. This change is OLTP. But if I took like the statement, so the statement would be, we can't do any changes in the statement. That is simple. So in OLAP, you just do the analysis itself. So this is what the OLTP and OLAP difference. Okay, so there are two different databases. One is OLTP and another one is OLAP. And we are connecting from OLTP to OLAP. And we are doing all the operations inside. This is what the main idea behind the behind anything what we are doing now. So I think if you have any doubts, you can ask before I'm going to the next concept. Okay, I'm moving to SQL. Just giving some, before going to SQL, I want to show you something. So, how many of you already created this community edition Databricks? At least one from you. So today I want to show you what is compute exactly. So here I'm creating one cluster. Can anybody give me what is compute exactly in general terms?
Computing power. I mean, it provides the resources to run certain queries or transactions.
Yes. Right. It will create, but meanwhile, we'll discuss something about it. Anywhere if you are saying compute is nothing but CPU plus some internal RAM. Okay. Next, disk means external memory plus network. If I go for my task manager, you can see that what is computing. See? What I'm having here, CPU, memory, disk, network. So compute is nothing but a processor and then with some memory, internal, and then external memory, and then network. So you must remember that a compute is nothing but CPU, RAM, disk, and network. If anybody asks you what is compute, then you must remember this. So what will do, what the CPU will do, what RAM will do, what disk will do, you know, all these things. Those are very basics. But you know, if you want to execute any kind of operation, if you want to do, then what we require, a processor must be there, like who will process all these things. So that would come for CPU. And RAM is, what is the purpose of RAM? So before going to any changes or anything, it will store the data in the temporary storage. Then if you require some storage external, then you need some disk, and to do all these things you need some network. So this is whole, like if you are saying a compute means you are having CPU, RAM, disk, and network. Then what is cloud compute? This is general compute. We are discussing this one. Now we are moving to cloud, right? What is cloud compute?
Same thing on cloud environment like Azure, AWS, Google.
Yes. So it would be virtual desktop. Very correct. So what's your name? I didn't saw that. Okay, Srikanth. Am I right? So he's saying that whatever we are doing on the cloud, all the CPU, RAM, disk, network, that would be cloud compute. That is right. That is the main idea behind this. Cloud compute is nothing but virtual desktop. So under the virtual desktop, what we are having, that we are calling as cluster. Okay. So likewise, we are having CPU, RAM, disk, network. In cluster also, we are having all this VMs, virtual machines, and internal storage and network and all these things. So while you are going for cloud compute, the virtual desktop is called as cluster. But whereas you, whatever you holding in your hand, that laptop, that is that you call as physical desktop, that is having CPU, as I have already showed you in the taskbar. Like you see in my physical laptop, what I'm having, CPU, I'm having memory, disk, and network I'm having, right? So the same thing we are having in the cloud compute also, that is virtual desktop. That who contains all these things, all these four things in the virtual desktop or cloud compute, that would be contained by cluster. So this is a cluster we are having here. So under the cluster, what we are having, the configuration, LTS is nothing but the developing version of the Spark. So here it 12.2 LTS, that is nothing but we are having Scala version 2.12, and that is 3.332. This is the developing version, latest version we are using. Okay. And driver type we are having, you can see how many, like how much memory we are having, 15.3 GB, right? See, free 15 GB memory. As a community edition, you will compute will automatically terminate after an ideal period of 1 or 2 hours. So if you are using community edition, so if you are not using that for more than 1 or 2 hours, the cluster is going to be automatically terminated. So without terminating one cluster, another cluster won't be created in the community edition. Whereas coming your official work, wherever you are using paid version in the office, so there you have multiple clusters. But while you working, you just preparing and you learning these concepts. That's why this is community edition provided by AWS and Databricks for their promotion. So this is, here we are having one cluster at a time. We are not having multiple clusters. Whereas coming to the what different, like where if you are using in your office and you are paying that, so at that time you will have many clusters. You can create different kinds of clusters. Going forward, we can discuss what is cluster and how many kinds of clusters are there and what is the purpose of different clusters and all these things. As of now, you just remember, without terminating one cluster, another cluster won't be happened in the community edition. And see how much memory it was having, 15.3 GB memory and 2 cores. So this is what the CPU here you having, okay? This memory, CPU and network. This is the cloud compute. We are calling this as cluster. This is virtual compute, okay? So in this cluster, you can, whatever you will find is, whatever the notebooks you have attached to this cluster, that would be shown here. And libraries you have used, and any libraries you used in that notebooks. So for that also will be displayed in the cluster. Event log, like how many notebooks ran and how many failed, and how is the driver health, and is compute running or not, and who created this, and everything will be under the event log. So this would be very important for you. Like while you working, you must know this event log. So suppose if you got any doubt over there, like my cluster is working properly or not, why my notebook is taking this much time and everything, where you can see those things, you can see in the event log. Okay, this is Spark UI, user interface. So you will have here what is the number of stages, jobs and storage, all these things you will have in the Spark UI. So after 2 sessions, I'll explain you what is the Spark architecture and what are these jobs, stages, storage, and everything. When you get aware of that what Spark architecture, then you might know this what are the jobs exactly, and what is the stages. So what is the storage you are using? See, like this, everything where you will get all the information. Just remember that at the time when you are working, don't go somewhere and you check everything. So it would be, everything would be under the cluster. So if you know the cluster better, then you can work better. So all these things you can see here. So what is that is streaming data, or what kind of data you are getting. So everything will be under the cluster. So these are the driver logs. This we can go inside. So what is this STD out, and what is this error, and what are the logs we are having, and all these things while we working together, you can get more familiar with those things. So any apps we have connected to that, all these things you can get it in your cluster. Okay. So already one cluster is created. So if you want to do another cluster, is that possible here? No. So you need to terminate this and you need to create another one. 2 to 5 minutes it will take to create one cluster.
So the size, the amount of compute is pre-decided, or we get to choose the
Here actually, if you are going with community edition, it would be like that. They will give you 15.3 GB memory with 2 cores of processing. Okay, but while you going for your pay-as-you-go version would be there in Databricks. So in that, if you're going with payment, then it would be you can select how much memory you require, how many cores you need, and what, like you can what you call personalize this cluster.
I mean,
Like
I mean to say, how would we know that this size or this capacity of the cluster would be enough
it would
to
be
run?
there. No. So if you want to, just for an example I'm giving, if you want to process 5 GB data, the cluster size must be 5 times greater than that, not to get any hiccups. Okay. So if you
Okay.
want to do 5 GB data, so you must be use at least minimum 5 to 5 means 25 GB. So most of the cases it would be like that. The cluster you are designing, it would be auto scaled. That is advanced concepts we are going for. While I'm teaching, you will get to know. But you ask now, so to clear your curiosity, what I'm saying is, the driver type here you are giving, right? This is community edition. But while you are creating original cluster, so then you can select what is the memory you require and how many cores you require, and whether this cluster is global or you can use by yourself, like self cluster, or many kinds of clusters are there, all purpose cluster, like that you can create according to your wish and your requirement. Okay, for this as of now they were giving you to prepare. So this one, just to practice this, we are getting 15 GB memory, so that is enough for us as of now.
Okay.
And this Databricks runtime also you can select over there, and everything you can select. It is like that, right? If you are paying, you can get everything. So I'll give you one DBC file in the next class, maybe after this free sessions. I'll give you a DBC file. In that you will get all the Python basics. So whatever your core Python main, whatever you require, that would be here. You can use this and you can practice well. But I'll teach you all the basics and whatever the requirement. So in this DBC file, you will get everything, how it would be and what is the Python identifier and why we are going. Before I'll give you at glance for almost 5 to 10 classes for Python and 5 to 10 classes for SQL. And after that also I'll give this practice set with you. Then you will be more familiar with this. So among this 14th is very important, 14th notebook. You will have all kinds of examples, what they were asking you in interviews and all. And then if you know this 14th notebook, then it is very easy to develop anything in Python. Yeah, this is what for today, I think. Anybody having any doubts? Just finishing it off early. As of now, it's fine. And too much theory. We just discussed today what is data warehouse and what is OLTP and OLAP databases and why we are going for that. And tomorrow we will discuss all the SQL basics and what we require. And before that, I will give you some 5 minutes. So, we have already discussed what are the big data types. Anybody from you? Structured data and unstructured, semi-structured, we are having all these kinds of data types, big data types. So here the SQL itself saying that what is SQL? SQL is nothing but structured query language. So structured query language means it is simply saying that it would be applicable over the databases. So we are doing this is not a programming language. SQL is not a programming language. That's why we are using Python also here. SQL is mainly designed for querying. So, if we are having one database, in the database, you need some of the columns and some group by, like some aggregations. If you want to do on the top of the database, on the top of the table, you can do some query operations. So SQL is meant for only querying in our whatever in data engineering daily day-to-day works. We are using SQL for just querying purpose, not for the programming purpose. Okay. So programming purpose, we are using Python. We are using Python for querying SQL on the top of Spark. So it is called as PySpark. I already gave this information in the previous sessions. So SQL stands for structured query language. So we are using this for structured data. So this can be used on the top of databases only. Okay, so this can't be used on the top of unstructured data, semi-structured data, and like that. And second one, we are having data query, data definition, data manipulation, data control. For this, I'll give you, data query. Querying means like how we are having in Python. Anybody can say what is query, what we can use for querying? Print, right?
Yes.
But in SQL, it is select.
Select.
So in Python, we are using print. In SQL, we are using select. Does both are doing the same function? Yes. But what is the difference? We are selecting. It means that we are getting some data from different from one database. So by using different aggregations, this is what. So this select is what? What kind of language? DQL, right? Data querying. So for querying, we are using select. What is data definition? Data definition, I can give you one shortcut. By that, you can remember anytime. Don't get confused. So this is DQL, data query language, and Dr. Cat. Just to remember, I'm giving just in a funny way. So what is this? DDL. Data definition. So by doing this data, what we are doing, we are defining the data, how the data would be, and what is that is a table, is that is a database, like that we are defining the data. So that is called data definition language. What is Dr. Cat? Anybody? Drop, create,
Alter.
alter, truncate. So if you remember just Dr. Cat for DDL, drop, create, alter, truncate. So only these operations would be there. Okay. And next, for DML operations, UID, user ID, DML. Data manipulation. What we are doing? We are manipulating
Update,
some.
insert,
Yes.
yeah,
Delete.
delete.
Yeah. So data manipulation means we are not creating any data. We are not altering any data. What we are doing, we are manipulating the data. Means, as you know, in the OLTP, we said that suppose 50,000 is going to be withdrawn by 20,000. Then the data, the amount is updated by 30,000, right? So like that, update,
Yeah, modifying data. Either
insert.
is
Yeah, modifying. Or you call test manipulation. Delete. And what we are having, grant and revoke. This we didn't use in the data engineering. We don't need this, but anyway, we must know. So this is for
Data control.
data control. So data querying is, we mainly use these three only. Data control language we don't use here. So we are having these three only. In these three also, data query itself showing that it is just selecting. It is querying. Query means questioning, right? What it is, like querying means questioning. So you just questioning the data. What is the like average of some fields, some like that. So you just querying. For that, what you are using, select. In Python, it would be print. Data definition language, I told you here it given create and alter. These are main things, but we are having two more things also. Drop and truncate also will come under DDL. And data manipulation, update, insert, and delete. We going forward, we'll know that what is the difference between truncate and drop and delete and all. And we don't use this. Okay. Actually, anybody know what is IDE? So IDE, we are using online compute for SQL and anything. If you want to use, you can use IDE rather than using SQL server like that. So in just go to the browser and you can give, suppose for Python, what is IDE? Mostly Jupyter. Jupyter notebooks are for Python. This you call IDE.
What is the full form? ID integrated or something?
IDE. Wait.
Yeah, development environment. Integrated development
integrated
environment.
development environment. So IDE, if you are using IDE, means like you are going on you need not to install a tool and use it. You can use simply, suppose if you are having SQLite, that is for that is an IDE for SQL. You can do all the things. And one more thing I want to tell you, if you are if you want to search or if you want to go for any querying purpose, if you're having any issues in your work also, you can use this website to get easy understanding. W3 schools. So under this, you will have all kinds of languages here. You can check it. See, Java, SQL, Python. Suppose if I want to learn SQL, then I'm having all these things here. So you follow while you are working at this W3 schools are very good to understand, easy to understand. Suppose if I'm like, see, I'll have one query on and I can use, they will give the demo and you can write the code by yourself and you can check it whether it is working or not. So my suggestion is go to W3 schools and you learn whatever the language basics you will have, and you will have good hands-on with this. Okay, so I'm suggesting this website for you, W3 schools. And if you want to work, you can use Python for Jupyter notebooks and SQLite for SQL practice. You can use those things. Anyway, we are using Databricks notebooks to use to practice the PySpark code. Okay. Today I'm wrapping this session. If anybody is having, you can ask me questions. Tomorrow we can go deep dive. Okay, guys. Thank you. Thanks, everyone.
Thanks.
Thanks. Yeah.